Perfect timing. Crouton Ramon's HouseOfMath.com. What? Last one we graphed was x squared plus 3x plus 2. And then for homework, I gave you x squared minus 3x plus 2. Alright. And you said you had some difficulty with graphing that?
Yeah.
Alright, no problem. No problem. So, he's going to help you. So once again, f of x and y are the same thing, right? This is a function of x. In other words, this is just... Whatever. Yes, I do. I'll put it up here. F of x is the same thing as y. Alright, that's another way of talking about this value, right? So here's x, here's the function of x. And what's the function? This is the function, this is the parent function. Okay, so you can factor that pretty easily, can't you?
Well, yeah.
Alright, well yeah, well then, there you go. We got 2 points already. We're like halfway through. You only need 5 points to get full points from me. So,
right.
Let's do it. What are the factors? Step 1, factor. As easy as A, B, C. As easy as 1, 2, 3. As easy as
X, Y, V.
F. Right? And we can do X, that's factoring X, Y, V, right?
Right.
Okay. X, Y, V, X. Well, first we've got to factor it and figure out where it crosses the x-axis. Go ahead, brah. That's you.
The problem is, I think it's completely leaving my head right now.
Well, get your blocks then.
Yeah.
See, and that's what I mean. That's why this is so that you don't have cognitive overflow and, we lower your cognitive load when you're taking a test. So this should be a gimme. That's why you spend a lot of time factoring. But anyway,
Right.
So goof around with it then. What are the factors?
Right.
I can look at that and I can tell you the factors.
When I did it before, it was like it was -1 and 6.
-1 and 6?
Yeah, which I don't think was it.
Dude, that Sensimilia you've been smoking is obviously having effect.
So it's minus 3.
So I'm just gonna say, before class, no more crystal meth. Just don't be doing the crystal meth before class. Okay? Alright.
I'll keep that in mind.
Alright. Try to refrain.
What
are the two numbers? What times what equals 2?
2.
And?
Well, 1.
1 and 2. Yeah, that's exactly it. 1 and 2. There are your choices.
Right.
Alright. What? Throw that one away.
So it would be
Ooh, that was the pen I was looking for.
It would be x plus 1 and x plus 2.
Well, and then I would have x squared plus 3x plus 2, but I don't have x squared plus 3x plus 2. I have x squared minus 3x
so
and 2.
Wait.
Let me make that point infinitely clear.
Okay.
There it is. Can't miss it now.
Okay. So in that case, it would be -1 and -2.
All right. Now we've got that part done. See, and that should have been the 0. That should have been the part where you didn't have to think. All right, so now that means it crosses the x-axis at -1, or excuse me, at +1 and +2. See, the other one we did on the other video, and if you're watching at home, you don't, right? We have a week between the last video and this, right? Whereas people that are watching this through the magic of time, because Einstein tells us there isn't any, and it turns out he's right, they could watch that last video and then watch this video right afterwards, right? Meantime, you've had a week and your brain has had time to fool around and play with it, so it's in the subconscious mind. I'm not worried. We're going to have a fun class. But now I see, I should probably back out a little bit and make some room over here to draw my graph. So, and then he doesn't draw a straight line. Oh, actually, it looks straight on the camera. Close enough. All right, so I'm over here at +1 and +2. It's going to be the exact same thing, except on the other side of the graph.
Right.
Okay, now, if all this is 0, what's y going to be?
2.
2. All right, so I got my y-intercept. Look at that. We got 3 out of 5 points. We're almost done. All right, what's the point across going to be? And he did some thinking about how that's going to work and so forth. Now, I'm going to label some points. This is x is 0, y is 2. This is x is 1, y is 0. This is x is 2, y is 0.
Right.
Got to label these points. All right, and this is 0, 0. That should be a gimme, right? We know the origin is nothing, nothing. All right.
Right.
Now, what's the point across over here?
The point across.
Yeah,
Oh, from there.
from here. What's this point?
Right. Well, it has to be.
Do you have a piece of graph paper?
3.
You can cheat and just get a piece of graph paper and look at it and tell me what the points are. But there's a quote-unquote mathematical way of doing it.
Mhm.
Graph it and hope for the best.
Graph it and hope for the best. There you go.
So I would guess that it has. That looks like 2.5
Oh, try again.
or 3.
This is 0 to 1.
Right.
This is gonna, oh, and what's my axis of symmetry going to be? Just looking at that.
Axis system. That would be 1.5.
I like it. I like it. 1.5 is, right? Negative b over 2a is that formula. So the negative is obviously positive because a negative negative is positive. So there is my axis of symmetry right there at a half. And like I said, if you can't remember how to do vertex form for some reason, then all you would have to do is put that 1.5 back into your equation. And that would tell you when it's 1.5, what is, when x is 1.5, what's y? Right?
Right.
Because what are we studying here? We are studying the relationship between x and y. Right? Well, this is the same. This is x, this x and y, but f of x and y is just another name for this, right? What happens when I put in 0? Well, when I put in 0, when f of x, the function of x, and this is the parent function, when I put 0 in over here, well, then I get 2. There it is. When I put 1 in for x, I get 0. When I put 2 in, I get 0.
Right.
Right? All right, so now, what's the point across?
Wait, why would you get 0? Why would you get 0 if it's 2 or 1?
You tell me.
Well,
That's a great question.
All right.
Why?
Right, because it goes down.
No, and dude, that's the questions. Those are the questions I like to hear. Why? Right? Why do you get it? Well, because when I get 1, then that turns into 0, and anything 0 times anything is 0.
0.
And those are the factors. I can also put it in if I want to do it the hard way, and you know, I enjoy my mathematics. Let's see here. 1 times 1 is
1.
Minus 3 times 1.
-3. No, -2.
Negative 2 plus 2.
0.
There you go.
Right.
That's why.
Yeah.
It's much easier to just say 0 times anything, but if I put it in, I can do the same thing with 2 or any other number when I put in the function. Same thing. In a minute, we could do 1.5 squared, and then multiply, or then subtract 3 times 1.5, and then add 2, and that'll tell us what that point is here. And I already know what it is. It's like right there. Bink. But anyway, what's that point? I'm getting old over here.
Okay.
3,2.
Why is it 3,2? You're correct. I want to know why, just like he said, just like he asked.
I did it the same way I normally do it, where it's just 2 out from
What's that number right there?
3.
Hmm.
Ooh. Ooh.
Let's see if that works every time. But yeah, from 1 to 2, that's where I was going before I got sidetracked on the vertex form. From 1 to, from 0 to 1, 1. From 1 to 1, and then 1 more, 1. Right? There it is.
Okay, x squared.
And also, if I put in 3, what do I get?
What?
Wait, what? I'm saying that the distance from here to here, from here to here, and from here to here are the same.
It's
1, 1, 1.
right.
Are you graphing this? You better graph this. And I hope you have graph paper.
Yeah, I'm graphing this.
Alright, good. Then, let's put in 3. What's 3 squared?
9.
Minus 3 times 3.
9,
Okay, so 9 minus 9 is?
0,
Plus 2 is?
2.
There it is.
Yeah.
Because there's 2 solutions for 2. Because there's always going to be 2 solutions. But anyway, at 0 it's 2, and at 3 it's 2.
Okay, I see it now.
Now we got one more point. Oh wait, and we didn't do this where I had to find 0, right? So to find y, how do I find y? Go look at your other notes. What is the second line?
The y-intercept.
Yes. So how do I get the y-intercepts? What did I write?
Did I not write it down?
I don't know. But I said there's x, y, v. So what's the second thing we do?
It's y-v. Well, I know for y-intercept it's the y equals mx plus b, but I don't know if that's what you said in last class. Yeah.
Y equals mx plus b, that's straight lines. That's a whole other thing. What goes here?
Okay.
I have it written down. Y-intercept form. Yeah. 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 Y-intercept form. So. Just look in my notes on how to get there. I have it somewhere, like a map.
Let me see if I wrote it earlier. I don't think I wrote it any earlier than this.
The two of you teenagers are annoying me, just so you know. And particularly you, because we've done it 100 times. And see, obviously you have to do it 100 times more.
Oh.
Neither one of you, really.
I really don't know. Yeah.
This is why, if I'm writing, you're writing. That's called taking notes. So, what goes there for y?
Well, it would be the 2, right?
It would be the 2.
Oh, you just. Oh, okay.
This is what we're doing, right? We zero that part out to get the y-intercept. Alright, now, how do I get v?
Alright, so the. Well, it's the axis,
Yes.
but.
It's the axis of symmetry. What do I do?
Yeah. Oh.
Remember we did that whole thing about squaring numbers that end in 5? What do I do?
Yeah, I remember. Oh, yeah. I have that.
What do I say? Your note-taking is heinous. And even worse, like I said, how many times have we done this? And you have no answer. Just a blank stare. Alright, you on the other hand, you've done it once. Him on the other hand, he's done it I don't know how many times. Alright, so what do I do for the last one? Vertex form. How do I set it into vertex form?
I'm trying to remember. I have the page of the 5 squares. And then how you maneuver it over to the
Maneuver
other side.
it. Alright, so what do I do to get vertex form?
Right. With
What's the first thing you do?
Take the other.
to get
Oh, okay.
First thing I do is I take x squared minus 3x And then I gotta complete the square.
That's what the complete the square is. Right here.
Ooh, okay, so it's 1.5.
Right.
Seriously? Anyway. Write it down.
Right.
2.25.
Alright, then what?
Wait, how did we get 2.25?
Because I completed the square. I took this. I took this. I took this. Right? And then I had to take one of these.
Right.
And complete the square.
Right. Right. Where did we get 2 x's from, though?
What? There's 2x, there's the third x. There's 3x.
Right. Oh. Okay.
So what are you doing? You're taking your x and you're dividing it in 2, which should be 1.5 and 1.5, and then completing the square.
1.5.
You all cut slack. You get no slack.
Right. I still don't think I get it.
What are you not getting?
I'm trying to see it. I don't know, I just don't see how it adds up to 2.25.
What's 1.5 times 1.5?
2. That would be the 2.25?
There you go.
Okay. Okay, and I need to write this down because it's still...
Yes. You should have wrote it down last time. What do we do to make vertex form? First step, complete the square.
First step, complete the square. Right.
Now, here's the
I have
thing.
to do this.
If this is x squared minus 3x plus 2.25, what's my parent function?
Oh! I see it here. I see it here. It's the...
It's my parent function of x squared minus 3x plus 2. So is this and that same?
Right. Yeah, it would be same.
Really? 2.25 and 2 are the same number.
Oh, no. I thought you were saying the middle number. The middle number were the same.
Okay, so this, and no, I'm talking about this whole thing. This expression right here and this expression right here. Are they the same?
They're different.
Alright, so how do I make them same?
Minus 0.25.
You get rid of the 2.25.
I minus,
Or you...
I take away 0.25.
0.25. Right. Right.
And then put some English in your notes. Why did I do this? Well, so now I can do this. This is x, right, minus 1.5 squared minus 0.25. Did I just not factor this and make it a square and make the side same? Well, there's my vertex form. And what is it? There is my x, and there is my y.
Right. Okay.
And now I have 5 points. And like I said, if
Yeah.
I didn't know how to, if I couldn't remember how to do this, then I would just take 1.5, put it back in over here, I guess would be good. And what's 1.5 minus 1? Well, 0.5. What's 1.5 minus 2? Negative 0.5. What's negative 0.5 times positive 0.5? Negative 0.25. There's multiple ways of doing this. If you don't get it right after this hour, that's on you. Now, take notes and put English in your notes.
Right. So, right, you making it the same.
So now,
as
basically,
y.
I do this part over here in y. I want to make this part 0.
Right.
Right?
You want the parentheses to be 0.
This part here needs to be 0 so I can figure out what's going on with my y. Super easy. Just cover it. I mean, there you go. Done. Right? But, oh, that only gives me one of the solutions. There's 2 solutions. The other solution is going to be 3.
Right. Right. And then, right. Got it.
Alright, can we go on to... Oh, wait. Last thing. Let's draw it. Let's see if I can make it. Ugh, terrible. Alright, there you go.
Oh.
And then don't forget, these go on forever in both directions. Right? Now, here's the point where it's not going up and it's not going down. Right there is negative 1.5. Oh, excuse me. Positive 1.5 that way. Negative 0.25. There you go.
Right.
So I'm not even going to put the...
Oh.
And that's this point right here.
Huh.
1, 2, 3,
So
4, 5 points.
What?
Go ahead.
My question is, what happened to the x and the vertex there at the bottom with the x minus 1.5 squared minus 0.25?
I don't understand the question.
Okay.
You answered your own question, but I didn't understand the question in the first place. What did you say? What happened to the x where?
Okay. What happened to the x there in that f of x?
Oh, which one are we talking about?
Right.
Because technically I can get rid of all of this. There's my v. My v is... And each one of these is f of x, right? I mean, do I have to... Let's find the algebra purists out there.
Right.
There are the 3 forms.
Okay.
X, get the y, get the v. As easy as 1, 2, 3.
Right.
Now here, there's 2 solutions. 0 works and 3 works.
And 3 works. Right.
Which is the opposite of that. But I think let's do a couple more and see what happens. Let's try and graph them. Okay, so 1 does not a pro make. So this is just x squared plus 3x plus 2. I just did the other one is over here, right? It's the exact same thing except over here. It's actually tessellated. It's a mirror image. And they both go through the point 0, 2. That's the one point they have in common. Right? If I did x squared plus 3x plus 2. And you get a graph that looks just like that flipped over on this side.
Mm-hmm.
That was the first problem we did.
No, I get that. You can just count. You can count the distance and see where the points are there.
Yes.
I get that.
Alright.
Yeah.
Are you ready for another one? I would give you x squared 4x and 3. Let's do x squared 4x and 3 because it's super painfully easy. See how badly you monkeys panic on it. And the other thing going on here is, it's algebra. It must be hard. It's algebra. We're graphing ball. There's nothing hard about this. Right? I gotta find, there should be video someplace of a 7-year-old doing this. 7! It's not because he's a super genius, it's because it's easy. Right? The only part that's hard about this is in your head, between your ears. You've decided that this is algebra and blah, 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 blah. Alright, ready? You don't look ready. Are you ready?
I'm as ready.
Ready as you're gonna be. Alright, I'll take it. F of, wait, here we go. How about you? Alright. How many times do we have to do these? Like I said, take notes. He thinks he's gonna skate because he's the teacher's son. Actually, it's worse on the teacher's son. F of x
I'm aware.
equals x squared. We're start with plus 4x plus 3. There you go.
Okay.
Completing the square on this one should be a no-brainer.
Right. So we have it's positive.
Factors.
Yeah. Yeah. No. It's for x. You have right. So you have x plus 1 and x plus 3.
I'll take it. Alright, so now I know my zeros where it crosses the x-axis.
With that, and then the x's are negative. Right.
So, again, this expression and this expression are equal. Let's do it again for the y's. Well, then it's just 0, and what's the other number that's going to work there?
So right. So x plus 3. Wait. The right. 0.
What's the other number that's going to work excellent for making that a 0? Making this part 0.
Right. Oh, right. To make that 0, and then you have 3 on the end.
Yeah. So I want to know, what makes it 0? There's two
What makes
answers.
it 0? Oh, okay. Right. So you need negative 2, or no?
What's the first answer?
You'd need negative. You would need negative 4.
Well, gee. Not that it's staring you in the face or anything. But alright, so there's negative 4. What's the other answer that makes this 0?
Negative 4.
And?
Positive 4.
Positive 4, my butt.
No.
Negative 1.
Oh, for God's sakes.
Positive.
A duck. Small stones. It turned me into a newt. Oh, for God's sakes, what makes that 0?
Right.
3.
Are you kidding me?
That works.
You're saying.
But where are you going to get a 3?
X equals 0, right? Isn't that
Yes.
the question?
How about 0, you big fat dorks?
0.
Isn't it?
Yeah.
Oh my God.
Plus. Yeah. 0 plus. Yeah.
Uh,
Oh.
yeah, I know.
Okay. No. Yeah. Because the 0
Yeah,
makes.
yeah. You can stop now.
We're both sitting there like, we should have seen this.
Yeah, it's kind of, alright, kind of sort of, you should have seen this. Okay, so I'll tell you what, I'll throw this over here. And this is the teacher's fault because I introduced stress into their brain systems by yelling at them. Alright, so. That's why you want humor. Humor works. Alright. Yeah, that was pain for me too. Okay, so. Let's see here. I've got negative 1 and negative 3. I've got 3. On the other side over here, I've got 4, 3. Look how fast I'm doing this. Oh my God. He's a genius. No, I'm not. It's all right there in front of me. All right, last thing. Oh, what's the axis of symmetry going to be?
Give me a second.
You don't get a second.
It'll be in the middle.
It'll be in the middle. It will be in the middle.
Which
That's
is of
true.
X. It's negative 1. Negative 1, negative 3, so it has to be 2. It has to be
I
2.
like it. And gee, what just happens to be negative b over 2a? Oh, that's right. 2. Negative 2.
Yeah.
Let me put that right there.
Oh.
Right.
Axis of symmetry. That's this red thing right there. Alright, now I look at this and I dump my pens over It's okay. Don't go back in the box easily.
We're just gonna leave that there.
We're gonna leave it there for the moment. Alright, then what? Now I need my last form,
Right,
my
okay.
vertex form. I'm just overanalyzing. That's all they want you to do, right? I'm just totally overanalyzing this parent function. I
Right,
factored
so-
it. I
right,
figured
it's
out the
one-
y-intercept. And
minus
now I'm
1.
figuring out the vertex.
Minus
What
1.
completes the square here?
4.
Right? Because I put 2 on one side and 2 on the other. Can you see this in your head? That completes the square.
Right. C4
Right?
and square.
Okay.
Completes the
That's
square.
why we did
Right.
that whole lesson on squaring numbers at n and 5. Alright. Then, but it's not 4. What is it? So if I did that, if I complete the square, I do x squared
Right.
plus 4x plus 4. Is that the same as the parent function? Anybody? Is that the same as the parent function? It's a yes or no question.
No, that's not the same.
Alright, so what do I have to do to make it same?
You need to get rid of 1.
I need to get rid of 1,
Subtract
so I'm just going to subtract 1. Alright, now can I factor that super easily?
Subtract 1.
Well, yes, I can factor that super easily. That's the whole damn point of doing it, is that I can factor it easily, right? It's a square. We completed the square. So what do I have?
Oh, this is a very nicely graphed one. It's not
Right.
like floating in the air
So
or
it's
anything.
x, right. So it's x plus 2x plus 2.
It's x plus 2
Or
squared
x plus 2 squared. Right.
minus 1. That's it. Are all 3 of these the same now?
Yep.
Well, technically all 4 of them, but 3 synonyms for the same parent function. This, this, and this. These are just synonyms. It's the same thing. It's the same blocks.
Right.
Alright, so now what? And then I gotta take the opposite and see children, who are being groomed to be kids, can see, oh, well, I make a rule. It's the opposite. Well, of course it's the opposite! Of course it is. So it's negative 2 that goes there. And then 1. Let's go a little further down. Alright, there he goes. And see with Desmos, you just punch them right in and they're done. Meow, meow. Now, let's say you gave me this as a graph on your homework. How much credit would you get for that graph?
100.
Right.
100.
0.
It's a right graph.
You would get no credit for this graph.
Well, I would get. Oh.
You would get 0
Because I
credit
didn't
for
put
that
the
graph.
points, right?
Why? Yes, exactly it. Because you didn't label any points. Well, not you, me. I didn't label any points. But if you turn in a graph that looks like that, that's a 0. So right here, I'm gonna label this 0, 3.
So what would you have to do differently?
Just label your damn points. And then I would do this as 4, 3. And then I would make this x is negative 3, y is 0. X is negative 1, y is 0. And then for the group de resistance, the last one is x is negative 2, y is negative 1. Now you get credit for this graph. And I was in school, I had a German math teacher, he gave me a hard time. If I did that, I would get credit, I would get points taken off. Because there are no arrows on the end of my things.
Okay.
Also, you might want to label your axis of symmetry, just for the sheer giggles of it. That this is, what is this? X equals negative 2.
It's negative 2.
I don't care what y is. X is negative 2. When x is a million. Right? Right? Do I care? Right? All the way up here. It's the same. All right? X is negative 2. I don't care what y is. Right?
Right.
Because
Right.
whatever y is, x is negative 2.
Right. So you you know.
Oh, and I spoke wrong. It's supposed to be when y
is always
is a million.
Right.
It's x is still negative 2. When y is 0, x is still negative 2. When y is negative infinity, x is still
Right.
negative 2. Right? That's my axis of symmetry.
So it would be negative 2 in the problem on the right, with the right.
And that's where he made the discovery. Well, that's why when later on when we start doing quadratics and stuff like that, we always divide by a, so that we always have just one square. Anyway, all right. Let us continue. Was that hard? Now, you should be able to do that in about 2 seconds. Hurry up and do it.
Okay.
Hurry, Hercules.
Okay.
All right.
So it's negative 4
Ah.
now. So you just reverse all the signs,
Yeah, there you go.
and you have a plus 1 on the right instead of a minus 1 now.
Mm-hmm.
Oh, okay.
Okay.
In fact, you could graph them together.
So then, yeah.
And you're going to get something, I'm going to make a mess now. We're going to get something that looks
Right. So then, wouldn't it just
it's
be on the opposite
yeah,
side of
like...
the?
That's exactly it. Don't talk about it. Do it.
takes like 3 seconds. Okay.
Hurry up and graph it.
So it would be the same points, just positive.
Yeah.
There you have it.
Literally the same.
There you go.
Except for 0, but it doesn't matter.
Yep. There you go. The same thing with the arrows and everything. So you have You still have
Like a matching
you
set.
still have the
Like a matching
the
set, there you
3
go.
over here,
Yep.
but everything else is just the opposite.
Yep.
And then over here, right?
Yeah.
You have 3. You have 0, right?
So I can see in your face. Like you see
Right.
the difference
So you
in
have
your
3,
face
0.
from the beginning of
3,
this.
3. I mean,
When you
3,
start, when
3
I
on the
first
right.
gave you this one to this one is completely different, because on this one you're confident, you know what you're doing, you're like, oh, okay, well it's just opposite, and you're just going through it, right? That's why I have to be able to see your face.
Mhm.
Same thing with him.
Right. So then this is 1 and this is 1 negative.
Yep.
This is 2 negative 1.
Yep.
2 negative 1 for the vertex. And this is 3 0 and then 1 0.
Right. And then
There you go.
this is still 0 3, and then instead
And an x would
this
equal
is
2.
Yep.
I mean,
And I left
yeah.
the sign off because this is it should say negative 4. All right. Other than that,
Yeah.
let's make that clear. Negative 4. All right. And I remember getting, anyway, I can remember some of the arguments I used to get in with my teachers. But see, you cannot argue math. It's as simple as that. You're either right or you're not. And if you think you're right, you should be able to explain why you're right, and there is no argument. Because it's mathematics. Right? This is why that it was great. This one doctor with the COVID-19, he did a bunch of... So he showed his formulas, he showed all his math, how he did his statistical regressions, everything, and he goes, "You can try it yourselves, right? Check my math." And guess what? He was right. And it's fun. Here's a math problem for you. You can show your mom, and you can show your friends. You can use it to impress your enemies and intimidate your friends. Go through the COVID-19 statistics and. Pick the numbers out and just do total number of cases, total number of deaths. And then just take total number of cases from Republican states and total number of cases from Democrat states. Then take total number of deaths from Republican states and then take total number of deaths from Democrat states. Just have a fun time. It's a little math. You gotta do some addition. You got a calculator. It'll work. But just add up the numbers. And then you can do a percentage. And see, what's the number of deaths to cases in Democrat versus deaths to cases in Republican? I think you'll be surprised at the number, actually. And the difference is huge. Huge! Huge. And you can make all kinds of excuses like, oh, the Democrats control the cities. Okay. But then take the population of Tokyo and then take the population of New York. Do cases in Tokyo, do cases in New York. And I think you'll notice that Tokyo is a little bit closer to China than New York is. And do the numbers. Right? The number of cases in Japan, deaths in Japan as compared to New York, it's night and day. And by the way, they didn't quarantine. Anyway, we got sold a bill of goods. Something else may have happened. Just saying. Something else may have happened. Might want to just do some math, do some numbers. Just do some numbers. Okay, let's do another one because so far we've done 2 and 2 is not enough. That was so lovely, I hated to erase it. Alright, shall we get crazy?
Oh no. Oh no, he's going crazy.
Okay.
I'm not even helping.
Plus 6. Okay. F of
I read
x.
it. I'll do the same.
Okay, so we have x.
You just wanted the eraser. I mean the sharpener.
Right, so that would just be 2 and 3, so it's positive 2, positive 3.
Alright, race, get it done.
X plus 2 and x plus 3. X
Alright.
plus 2 and x plus 3.
I like it.
And x is equal to
Just give me a graph.
Right.
Yeah, just
Equal
go.
to
Just go.
negative 2 and negative 3.
Yep.
Okay.
So the answers here are 0 and
Y.
5, oddly enough. You're at negative
right,
5,
it's
actually.
X squared plus 5x. Right, and then you have 6 on the outside plus 6. Right, and to get rid of this, you have y equals. You have 0 and negative 5. Right. Okay, yeah, I get that. Okay.
And then see, then I can make
And then.
my
the-
points. What are my points going to be? Well, when x, because all this is I'm giving my solutions for x, so you have to throw your y in there when you
Right.
graph it, right?
So, yeah.
All right, what's the last one? Vertex form is what we're actually working on. What this module, what this hour is about, is
Yeah.
actually making sure that you can do vertex form.
Hang on, let me. Right, negative 3. Hang on, I'm just writing down little notes.
Good. That's good.
Okay.
Write down lots of little notes. I'll never belittle you for that. Put as much English in there as possible.
Yeah. Right, so you have 0. Right. 0. Right, 0, negative 5.
No.
Right, okay.
What?
So then V is the middle point divided by
All right.
2. And then
Yeah. So
plus.
wait a second here. Oh yeah, the vertex. The vertex is what?
Divided by
What is
2.
my vertex?
Right.
Fine, I'll write that down over here. Tell me the vertex. Or excuse me, not the vertex. My axis of symmetry.
Right,
The vertex is a point. AOS. Get the term straight.
Squared.
It's just-
right,
it's
divided by
just-
2 and
My
squared.
axis of
Right,
symmetry is
so
just
it's-
negative
It's
2.5.
2.5.
There you go.
Right.
All right. So when my axis of symmetry is 2.5, what's my vertex? So over here, look, you know your x portion of it. It's negative 2.5. What's the other part of that point?
It's 2.5, and then the y is.
See here,
the
this
square
is
of that.
x. This is v vertex.
Again, minus
Right.
2.5. Right? No. Wait.
Just do it.
5. Right. No.
But isn't it? What's 2.5 squared?
No. Oh. No.
What's 25 squared?
2.5 squares is 6.
625.
25 squared is. From 600 something.
Okay.
I have it here.
I mean, technically-
You shouldn't have to look back at your
625.
paper.
No, 625, right. I had it.
All right, you don't have to look at your paperwork.
It ends in 25.
It ends in 25 and it starts with 6. So what's that number?
6.25.
Right.
Yeah.
Because what I do, I took this and I said, look, this is x
6.25.
plus 5.
Right.
Or excuse me, x plus 2.5 squared, and then I had to take away something, which turned out to be 2.5 again. Because 25 squared equals 625. That's why we did that whole lesson on squaring numbers that end in 5. See, and if I make 2.5, then, oh wait, let's make it clear. This is why, see, this is what parents don't understand. Why are you teaching my little 7-year-old how to do square numbers that end in 5? Because it's fun. And then when we get older, it's not just fun, it's quite helpful.
Right. 0.25. Right.
Yeah. Because if I don't take away that 0.25, I don't have the same number. I have 6.25, and that's not my parent function. Now you can graph it.
Right.
Okay.
Oh, jeez. I'm supposed to say
Okay.
point.
So then,
There you go.
Oops. Oops.
Now, show me
Okay.
your graph.
I've done an oops.
so you
Give me a
have
second.
right
An oops.
2.5. Right. Yeah. Right, because that's the square.
And this is the thing, if I put negative 2.5 back into this function over here, that's what I'm going to get, is 0.25. And I can actually just take 2.5 and put it in over here, and that'd be super easy. And I'd wind up with negative 0.5 and positive 0.5. And negative times positive 0.5 is just 2, right? 0.25, negative 0.25.
2.5.
All I'm doing is saying, look,
Right.
what is it? How do I find my axis? Negative
Right.
b over 2a. And of course 5 is the other portion of the 0 here, because, well, in negative 5 in this case.
Right.
Right?
Mhm.
And if I made this negative 5, then it would be the opposite. It'd still be 0, but then I'd have positive
I
5.
get lost at the vertex. That's where I get lost.
Why are you getting lost? Just write it down. What's the first thing you do?
Yeah.
What's the first thing you do?
Do the factor.
Do you do the factor? No. What's the first thing you do?
Oh, you mean in the vertex? Well, I have right. You have x.
Starts with a
You have
C.
X.
What's the first thing I do?
C.
Starts with a C.
Oh, complete the square.
That's the first thing you
Complete the
do.
square. Right. Complete the square.
Step 1. Complete the square. Why do I play with little kids and make them complete the square? Because it's fun. If I have x squared and 6x, it's fun to take half of them over here and half of them over there and put a pink square in the corner. If I have x squared and 8x, it's fun to take half the brown ones and break them into blue and then do a yellow one on each side. And then, can you see it in your mind? Right, I have my big red square, I have 8x, which is a big brown
Okay.
one, and then I want to complete the square. So I put 4 over here
Right.
and 4 over
On
here,
both
and then I put a
sides.
big yellow square in the
Right.
corner. And that's completing the square
Right.
with x squared, 8x, and 16.
Right.
Right? We're just playing. At that age, we're certainly not trying to graph polynomials. What are we doing? We're learning that 4
Right,
times
so
4 is
this is-
16.
right,
We're learning that
right,
half of
so
8 is 4.
one.
We're learning that 4 plus 4 is 8. Right?
So right, it's 6. It's 6. I see it now. It is 6.25.
Yes. Because this just happens to be, alright, so the next one we're going to do, you two make me sad.
Right.
But alright, fine. The next one we're going to do, so, oh wait, what do you do after you complete the square? In vertex form. When I'm turning into vertex form. My first step is
you have
complete the
answers,
square.
and then you make it same. as
Make
the
it
original.
same, I'll take it. I'll take it.
Right.
Make same as parent function. Guess what? Your notes and my notes and some other person's notes may not be the same, but as long as you understand what you got to do, make same as parent function. So then you add or subtract whatever you need to make it same, right? Once you complete the square, right? And I'll just put in parentheses add or subtract to make same. Usually it's subtract. Just saying. And then there it is. There's your vertex form.
Mm-hmm. Okay.
Get it? Right, this is so easy. Okay, and I didn't even draw my...
Oh! Yeah.
Yeah.
Okay.
Yeah. Yeah. See?
Right.
Okay.
Yeah. Yeah.
Yeah.
Yeah. So it's negative 0.25.
what I
No,
like to
it's
hear.
negative 2.5 as the x, and then the y is negative 0.25 as the vertex, right? That would be
Vertex. The vertex is negative 2.5, 0.25.
0.25. Okay.
Because I had to take away. Well, what's this number squared? This number squared is going to be x squared, 5x, and 6.25, which is not this. It's x squared, 5x, and 6. So I have to take away the 0.25.
Right.
All right, let's do another one. Let's do another one.
So you just take it.
We're taking too long. Let's do another one.
Got it.
All right. Like I said, if I'm writing, you're writing.
Okay.
Dude, if you can do one of these, you can do any of these. That's the problem with many teachers. Is that they... Wow, my hair is a particular mess today. It's because I combed it out all nicely and then I didn't keep it that way. Where'd my other black pen go? I just threw it away. There it is. All right, the dark one. Yes, the one where I like... All right, what was I writing? I was going to make one that was super easy. I was going to do x squared plus 8x. Plus what number do I want on this one? I don't like it. Let's do, 50, let's do 12, just for fun. That way we'll have an interesting looking graph. So there's my alpha of x. All right, you're on.
Okay, so then... Right. So you have x plus 2 and x plus 6.
Got that part, yeah. Then what?
Right, so the x, the points, right, the points are 0, or 2, 0, right. I'm just writing this down quickly.
Yeah, just go. And then what's the next step? Well, then it's just that.
And 6, 0. Right. So then, right, then we have x.
And then just to get some cool color in here, let's go, let's go with some bright orange.
Right.
Oh, look, I'm done. Well, I'm not done because I still got to graph it. But I did everything I needed to do to graph it. Shall I extract points? I'll extract some points. Now I'm going to give you actual points. So at negative 2, it's 0. I got to graph all this stuff. At negative 6, it's 0. I got to graph that too. Let's see. Over here at 0, it's 12. And at 8, it's 12. Excuse me, negative 8, it's 12. And then over here, my vertex form is lovely. Is negative 4, negative 4. That's my vertex. There are my points. 1, 2, 3, 4. There it is.
Right.
Oops, nobody can see that. There. 1, 2, 3, 4, 5. There's my points. 1, 2. Those points are here. These points are up here, and that point's there.
Right. Yeah. Right.
All right, graph it. I want to see your graph.
I think you're very delayed. I can't hear you. Okay. Yeah. Okay.
Okay, what I said is I want to see your graph. Yeah, we were what do you call it? We were frozen there for a second because you were frozen.
Okay, I haven't graphed it yet.
All right, that's the thing.
It was so laggy that I couldn't even follow.
All right.
Right. X plus 4 squared minus 4. Right. Okay. So you have.
So what did I do? How did I do to go so fast? Remember, let's see. I cut that in half.
1, 2.
Right. I squared it, and I found that that's 16, but it's not 16. It's 12. So I took away 4.
Right, and then you square. Right. One, 4. Right. And then you have 8 over here.
Nothing. It's just amusing. He's got it though.
Okay. Right.
Show me your graph.
So like that.
Hold it up to the camera closer.
Graph.
Yeah, your graph sucks. You got what? All you did was give me the x-axis. You got to give me the y-axis too.
Yeah, your graph sucks.
Can't just give me a y-axis. Yeah, he's on. Yeah, you're right. You should feel embarrassed. You're correct. You should be a little embarrassed. You need both of them. You gotta have this and that, not just that.
Not laughing at him, but
Need both of them. Need the x and the y.
What?
Yeah.
No, what?
Could you be lazier?
I do have the X and the Y here.
All right, let's see it. Let's see again. Let me lazy. Well, let's see. Hold it up. To the
I have the axis.
all you had was all I could see was the x-axis in your drawing.
Isn't it what that is? Isn't that what it is?
Oh, okay. I couldn't. You know why? Is because at the angle I couldn't see the y-axis. I was like, what the heck? Because apparently you had it. You had the paper.
I had the bolded out.
Yeah, you had the paper folded.
Yeah, it is there.
Yes. Okay.
Yeah.
I was gonna say.
Yeah.
I couldn't see that line because of the way he was holding it. All right. Cause I was like, how are you gonna make a graph with just one axis? I mean. Bunk, bunk, bunk. Oh man, mine's worse. All right, wait. We'll do this. We'll put it way over here. Oh God. Make some straight lines. All right, now there's 0, 0. So what am I gonna have? I'm gonna be like at 2 and 6, and then I'm gonna be down here, way down here at 4, 4, and then I'm gonna be way up there at 12, 12. And then I gotta label my points that this is 0, 12. This is negative
12,
6.
12?
No. 0, 12.
You said 12, 12, and I was like...
And then what? Negative 8, 12. Oh, jeez. My writing. And then what's that? That's negative 6, 0. That's negative 2, 0. And that's negative 4, negative 4. There you go. All right. Oh, and I could put an axis of symmetry in there just for fun.
Right.
All right. I like your graph.
Right.
But no, seriously, when you're holding it, you had the paper folded, or like not folded, but it had a curve to it, and it made it so I couldn't see the Y.
Yeah.
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 All right.
Yeah.
I think we're cooking with gas here, and it went pretty fast, didn't it?
Yeah. Done.
All right.
Mhm.
So I'm gonna give you 3 for homework, and I'm gonna send you some more video. This time for sure, since you didn't find them, and I was supposed to send them to you last time, and then I forgot.
No, it's not done yet, right?
Yeah, we're done. The hour's up.
Okay.
That's an hour.
Jeez.
Yeah, goes by. I tell you,
If only my-
time flies when you're having math.
If only my math class back when I was in normal school was this went by this fast.
Normal school? I'll try not to take offense. Really, that's normal? If that's normal, that's sad. Because normally, what you're saying is that normally the hour would drag by.
Yes.
Yes.
Normally, for normal math in most schools, the hour drags by.
Yes.
And math
it's
is like the
it's an
worst
hour
class
of
the day.
pain.
Yeah.
Meantime, with me, math goes by instantaneously.
Felt like
You
20
sit down,
minutes.
and then it's time to be, and then we're done. And that's how you know you're doing it right.
Yeah.
You're still really delayed, by the way, if you're talking to me.
Okay, I am, but never mind. Okay, so all right, so we will continue on next Monday, and then be looking for. You should get something in your. Oh no! It sounds like the Rona.
The Rona.
And then be looking
Okay.
for. Be looking for your box in the mail. Okay, we just caught up with each other. We were lagging totally. But anyway, be looking for your box in the mail, and if I don't,
It's yeah.
all right. I was gonna say if you don't get anything, I'll type it to you. But if you don't get anything by say what's today, Wednesday, send me a note that says, hey, I didn't get any videos. Can you hear? Okay.
I'm listening. I'm listening to what you were saying.
Right.
Yeah.
Okay. So just
Okay.
send me a note if I don't get you videos by this week.
Yeah, it's just really delayed. Is that I have a delayed reaction because I hear.
Yeah. Okay. So let me give you 3 problems. To graph. Now let's make it plus. Oh, you know what? We'll do 10 just to make it fun. And here's a bit of a challenge problem. Oh, we'll do 2. There you go. Oh, and then
Okay. I wrote them all down.
oh, no, wait, I'll give you 1 bonus problem. 2x squared. Let's see here. 2x squared, and we'll just do something super easy like 5x and 3. Alright, so this is kind of a bonus problem. This is a super bonus problem. These 2 should be gimmies. Right? This should be easy. This is more of the same.
Okay.
This one you might have to think a little bit, but I don't think so. And this one, ooh, what am I going to do about that 2x squared?
Mm-hmm.
So you can always fool around the internet and find it also. Don't forget about Desmos. Desmos will be a clue. You can just punch it into Desmos, and Desmos will show you this graph. Right? And you can do the math behind it. I don't care how you do it, just do it. Alright, so anyway, there's 4 problems. Okie dokie?
Okay.
Alright.
Okay.
Do you have fun? Oh wait, questions? Yeah, other
Okay.
questions? Questions?
Yeah. No, I don't think so. I think I got it all.
Alright. I hope you took good notes, and I'll see you on Monday. Take it easy. Try not to drink any bleach. No Tide Pods.
Alright.
Alright, see ya.
You too.
GridDarmonsHouseOfMath.com for more.